Okay guys, the human ear. My name is Mr. Mpepu and today's date 30 April 2024 and the time there 39 minutes past 11. With that being said guys, sanbonani, dumelani, afsheni, hello, Ndra, guys, to all corners of South Africa and Africa Kabupara. I personally welcome you to my session or to my class, Learning Life Science with Mr. Mpepu. Today we'll be continuing with our human ear, hearing, and balance. So welcome, guys. Welcome. Thank you for tuning in. Thank you for choosing me. Thank you for following me. Last time I checked, we were at 120 subscribers. I really like to appreciate all the subscribers, and I can see those 20 views, 30 views. That shows that some people, they are following me on their daily basis, right? You guys, you are making me to be motivated to come here every day and deliver these lessons. So with that being said, guys, I appreciate you. I really like to appreciate you to take this moment and appreciate you. We started on the 18th of March, week 1, term 2, and then today marks a day here on our week 7. So with that being said, guys, welcome to my class. Those who are new here, don't forget to subscribe, don't forget to like, don't forget to comment, and don't forget to share, right? Thank you. This week, we are still dealing with our human ear, responding to the environment, right? We had our weekly plan. Let's do this Monday, Tuesday, Wednesday, Thursday, and Friday, right? You'll agree with me. Monday, we agreed that we are going to deal with the structure and function. If you missed it, go back and watch this video. And then Tuesday, we are going to deal with our hearing and balance. Wednesday, question and answer. Thursday, hearing defects. And then Friday, end of topic exercises. End of these topic exercises covering our human nervous system, our central peripheral nervous system, autonomic nervous system, nerve, and reflex arc disorders AD and MS, Alzheimer diseases, and multiple sclerosis. And then we're also going to cover human eye, yes. With our human eye, all those things same as our human ear, right? Structure and function, accommodation and pupillary mechanism, question and answer, hearing defects, and topic last week, right? So welcome, guys. Welcome. Thank you for choosing me. Thank you for being here. You could have been doing something else, but you choose to tune in. Then another thing, before we can move on with our class, don't forget to set this video on a full mode screen. Rotate your phone or rotate the screen so that the screen will fit on your cell phone screen. If you're using a cell phone, if you're using a computer, or if you're using a TV, set this to the full mode and also set this video to HD so that you'll be able to read whatever it is written on this screen. Relax. Those who are watching this from the smart board, co-classing, do the same. Relax, take the book out, write whatever we are learning. Those who are sleeping, those who are listening to, those who are learning while they are sleeping, also the same. Reduce the light, sleep, learn this thing with us. So whatever I'll be writing, I'll make mistakes, guys. I made mistake yesterday. I was rewatching my video and I checked, or I found that I'm making a lot of mistakes. If you can be able to rectify those mistakes, guys, we are good. If I want to say, maybe for example, I'm referring to auditory canal, and I'm saying optic nerve, rectify those messages, right? It's because my mind is still processing our human ear, right? So some words, I'll be putting them this side. So rectify those mistakes, right? The ventribule, yesterday I checked, I was referring to vestibule, I was saying ventral, ventribule, the utriculus, circulus, all those terminologies, right? Maculus, cristae. I'll make mistake, right? I even told you the beginning of our classes that will make mistake, so forgive me, forgive me. Thank you for being here. Thank you for choosing me. Thank you for learning life science with me, right? So thank you. Let's move on. Pass by our CAPS, our curriculum document. Our curriculum document, we are still under human ear. Then we learn the structure and function. Today we'll be dealing with our hearing and balance. At this moment, you have a small foundation, or you have a foundation where you can now try to explain what is happening with our hearing and what is happening with our balance. We talked about cristae yesterday. We talked about macula yesterday, this side, right? And yesterday we talked about our wavelengths, moving from our left wavelengths to our middle ear vibration, and with our inner ear pressure wave, right? Those liquid that are vibrating. So we have these three types, and then today we'll be laying them out and see the whole process of hearing. So with that being said, guys, let's move on. Our examination guidelines. With our examination guideline, we are still on the track. We did this Monday, structure and functioning, different parts using a diagram, right? They will need you to label this diagram, my friends. right? They will need you to label this diagram together with our human eye. You should be able to label the diagram. We have the pinner. I told you that you need or have that ability to sketch these diagrams, right? They have that ability to sketch those diagrams here. You'll need to see those three tiniest bone, and the other one hitting that, and then you have to see that what, and then the snail figure there. Then this is what you want to see, right? And then if you can sketch this, for sure you will be able to label that. I want to see the pin, I want to see the auditory canal, I want to see the I want to see the eardrum or tympanic membrane, I want to see the hammer, I want to see the anvil, I want to see the stirrup, I want to see osteochain tube, I want to see semicircular canal, I want to see the vestibule, and I want to see the cochlea, and then from the cochlea I want to see that auditory nerve. Thank you, guys. Then from there, human eye, today we are dealing with the function of the human eye. This is the function of the human eye. What is our human eye doing, or what is the function of this human eye? Why do we have our human eye in our body? What's the function of this human eye? The human eye is functioning for our hearing and our balance. I talked about this, that balance is brought upon our human eye, our human ear, right? Where in our cerebellum, right? So this cerebellum is going to coordinate our movement so that our skeletal muscles can can stay upright. Our body can stay upright, right? So as you can see here with our introduction, you see that we are including with our hearing, we have to outline this movement up until we reach our organ of Corti, which this will be the receptor for hearing, and then but without the details of its structure. So yesterday you'll agree with me that we cut that our cochlea there in half, and then we see the upper layer, the middle layer, and the lower layer. So today we are not going to include this information on our explanation. We are only going to say our organ of Corti is going to transmit that stimuli into an impulse, and that impulse is going to pass via our auditory nerve to our cerebrum, right? And then together with our balance, yesterday I told you we have the maculae and we have the cristae, where the cristae we found them in our semicircular canal, in our ambula, and then our maculae we found them on our vestibule, and our saeculus and our utriculus. So today we are only going to talk about these maculae here. They are going to dictate the position, and then these cristae here, they are going to dictate the speed and direction stimulus, right? So converting this stimulus into the impulse, and then after that, that impulse is going to be sent to our cerebellum and to our cerebrum, both of them, right? So that when you're able to identify what is happening with your body, and also the cerebellum to send those impulses to our skeletal muscles so that they can keep that posture, or keep that direction, or keep that whatever. You understand, right? And then here also without the details of the structure. So welcome guys. Those who have been subscribe. Those who have been like, guys, like. Those who have been commented, guys, comment so that I can see you guys. You can subscribe, but if you cannot comment there, I cannot see your subscription, because some of you have set that subscription to private, so I cannot see who subscribed, who's not subscribing, who is participating, who is not participating. So for you to be recorded as the person who is participating, like and comment. Don't forget to comment. Move on. You can just comment hashtag we are socializing. Simple stuff, right? You don't have to comment more stuff, right? As you can see, passing by our MTG Mind the Gap. With Mind the Gap 6.6, we are at 6.5, sorry, 6.5 human ear, right? This human ear, I told you that it's made out of three main parts, which will be the outer layer, the outer ear, the middle ear, and the inner ear. You should be able to label this, right? We have this part here. If you can label it, it's fine. We have that part there, we have that part here, we have this 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 part here. So you should be able to label these structures, all of them, and the functions, right? If you know that this one is an ambula, where do we find in ambula? We find our cristae. Thank you. And then here will be the cochlea. What do we find in our cochlea? We found those organ of Corti. So we are moving on with our revision, right? Fast. We know that yesterday we learned that we have the pinna. What is the function of pinna? The pinna is directing the sound wave to our auditory canal there. It's directing our sound wave to our auditory canal. And then inside our auditory canal or our ear canal, we say this one is transmitting those sound wave. Here we have three things that we refer to this sound. Here, the sound is at sound wave. And then from the sound wave, we can move on. I will say them when I move on, right? Sound wave here. Sound wave is going to vibrate that tympanium or tympanic membrane or eardrum. Anyhow you want to place this, these are the words related to this eardrum of ours here, right? We can say this one is a tympanic membrane or tympanium or eardrum, right? The function of this eardrum is to vibrate. While it's vibrating, it is transmitting the sound wave to the middle ear. Now we jump to our middle ear. Inside our middle ear, we found these ossicles, right? We talked about them yesterday, saying that these are the tiniest bones in our human body. And then the first one would be the hammer being vibrated by our tympanic membrane there. Then this hammer vibrating is going to vibrate our anvil. After vibrating our anvil, is going to vibrate our stirrup. With the vibration of stirrup, this stirrup is going to transmit now, or this middle ear, its function is to transmit the sound wave or the vibration, right? Here we talk about the vibration. At this moment here, this is referred to vibration because our tympanic membrane there is vibrating, and then while it's vibrating, also we talked about it yesterday, that it's going to amplify those sound waves, right? It's going to increase those sound waves, right? And then while increasing, how do we increase it? Because this one is big, this one, you don't have to know that, right? But just know that it is amplifying the vibration or the sound wave, right? And then these ossicles here, they are transmitting the vibration. This is what I was talking about. They're transmitting the vibration from the eardrum to the inner ear, these ossicles, right? And then while they are vibrating there, we are going to see the inner ear there. And then also another part there, we have the Eustachian tube, right? With Eustachian tube, its function is to equalize the pressure on either side of eardrum. This pressure here and this pressure here has to be constant or has to be kept at equilibrium. So the position or the part that is equalizing or that makes sure that the pressure it is equal, it is our Eustachian tube transferring the air to our middle ear and transferring the air outside of our middle ear to our throat, right? So we move on with middle ear, we get to our inner ear there. With our inner ear, we start there with our oval window. This is a membrane, and this membrane is going to be poked by our stirrup there. Then this stirrup vibrating or pushing that oval there is going to cause a pressure wave, right? We say that it's a pressure wave, right? This liquid inside is going to vibrate, right? That liquid in let's do this. This one is it's what we call this one is an intro. It's a revision, right? So you learned this yesterday. We spent 1 hour 30 minutes learning this. Then we have the oval window. That oval window is transmitting the sound waves or the vibration there to the inner ear, right? And then the round window there, it is releasing those pressure from the inner ear. That movement, so that is happening inside our inner ear. We have three parts. We have the semicircular canal that are bringing balance. We talked about this, that we have ampulla. Inside the ampulla we have cristae, and this cristae, they are going to detect the stimuli, speed and direction, bringing this balance here. And we also have the circulars and utriculars, also bringing about the balance to our body. How they bring balance there, we have the macula. This macula, they are going to detect the stimulus brought upon our position of our human head, hence bringing the balance here, right? So when we talk about the balance, we talk about this part here. And when we talk about the hearing, we are going to talk about this part here, which will be the cochlea. And this cochlea contain an organ of Corti, which convert the sound waves or which convert the sound stimuli into the impulse, right, into the nerve impulse. So here we found that that wavelength or that sound being our electrical signal passed by our auditory nerve that transmit the impulse to the brain, where cerebrum. And we also have another neurons there or another nerves passing there going to our cerebellum and our cerebrum, which is called vestibular nerve, right? But in our book, I was checking this. They are referring this both as our auditory nerve. Hence, yeah, we can argue that both of them, they are not auditory nerve. One is auditory nerve, the other one is vestibular nerve, right? But if you write this in your textbook or in your answer book that whatever, maybe the balance here, the stimulus that are going to be produced here, they are going to be passed or they are going to be transmitted via auditory nerve, they will give you right. But here, what you can take is that these impulses here, they are going to be passed by our vestibule nerve, this nerve here, right? All together they are called vestibulo I talked about this here yesterday, cochlear nerve, right? I talked about this yesterday. And then from the vestibule and the cochlea, this cochlea is the one that we refer to as our auditory nerve. So let me not confuse you, right? But this is what is happening either way. So you choose what you want to refer there. And then we have our activity there yesterday. Let's do this fast. If you still remember, I gave you this activity so that you go home and learn or practice this activity here, right? So our activity there, this one will be our correction. Let's do this for those who are following me or for those who watched this video yesterday and now they are picking up where we left, right? I even do this yesterday, auditory canal and our peanut there. So they said number 1.1, we did this yesterday, but if you can also do this today, let me fix this fast. If we can use this today, let's decode our question. We know that this one here is an ambular, number D, and then also it contains the cristae. Then this one will be our semicircular canal, and we have the cochlea here containing organ of Corti. We have the round window, oval window, eustachian tube, ossicles, hammer, anvil, and what? And stirrup, right? We have our tympanic membrane or eardrum, we have our auditory canal, and we have our pinna. So be able to identify those. We did this yesterday, right? So thank you for being here. Today, by number A, let's do this number. Identify part A, B, and E. A, B, and E. Which one is number A? Number A, the eustachian tube. I told you that they will want you to write this name. Eustachian tube. Right? Eustachian tube. And then number B, where is number B? Round window. Round window. Right? And then number E, where is number E? Cochlea. Cochlea. Something like that, right? Cochlea, however you want to claim that, but this will be the correct name. The round window, you don't have to claim that. Eustachian tube. Eustachian tube. Either way. Number 2, but provide the collective name for the bones found at C. State 2 functions of these bones, right? The bones. Then number C, provide collective name. We want to provide the collective name before we can come and state 2 function. So the collective name there, those bones are called ossicles. Right? And the function, we need 2 functions. The first function is to transmit, right? They are transmitting, you'll agree with me, they are transmitting the sound wave. You can say they are transmitting the sound wave, or they're transmitting vibration. To transmit vibrations, to transmit vibration from eardrum or tympanic membrane, eardrum to the inner ear, That is the function. Another function is to amplify, right? Those tiny bones, they are amplifying. We can say to amplify from the amp, right? We have the amps there, the home, to amplify the vibration. The vibration. We have amps at home. You know the function of amp is to increase the volume, right? Those who are doing music, you have the phone, you have the speaker, and then you have the amp, right? So this is what is happening. That will function as our amp to increase those vibrations, right? And then number 3, the structure labeled D contains receptors. Where is D? This will be D, right? Then this will be ampulla. This will be ampulla. Ampulla. Containing, they say it contains the receptor, and those receptors we know that are crista. Right, so we can go and answer the question. Number A, but name the receptors found in the structure. We have named that one will be the crista. Many cristae. And then number B, give the stimulus to which these receptors respond. These crystals, they respond to the speed and direction of the head. This is the stimuli. When our head is increasing the speed, or when our head it is moving in a certain direction, those stimuli, they are detected by our crystal. So we can move on, right? You'll agree with me. We can move on to today's lesson, function of our human ear. You know all those parts. Today you even know what is happening with our hearing. You did this last time, so we can just move on and see how they are, or how they want us to learn this functions, right? But the function of the human ear, thank you for being here, thank you. And then this function has two functions. This ear of ours has two functions: hearing and maintaining balance. For you to stand up and walk upright without falling to the left and falling to the right, the maintaining of that balance is brought upon by our human ear, right? So thank you. So with our hearing, we are going to do them today, two of them. So let's go and move. And then hearing here, we say this one is going to be organ of Corti, and then this one will be those cristae and maculae, right? Bringing the balance, these two, bringing the hearing, this one. So let's go on. But hearing, illustrated in figure 24 below, is the process in which sound waves are transmitted through the ear and impulses are generated, which are sent to the cerebrum for interpretation. The hearing is a process. When we are saying, can you hear me? There's a process that is happening. You know that the process has to have the start and the finish. We start somewhere where we are welcoming those sound waves. And then those sound waves, they are going to be transmitted up until they are going to be generated as an impulse. And then that impulse is going to be sent via auditory nerve to our cerebellum. So what is hearing? Hearing is the process whereby a sound wave, it is converted into an impulse in our human ear and sent to our brain for interpretation. When you interpret that you heard Mr. Mpepu saying, let's continue, there's a process that happened there. And then today we are going to learn that process of hearing. Thank you. Right? So this will be the process of hearing. You can see the arrows indicating how our sound wave is going to pass up until it reach our cochlea, from cochlea, our auditory nerve, into our auditory nerve, straight to our cerebrum. Right? So we have three things, or we have three parts here. We have the first one, this up until here, we refer these arrows as our sound wave. This will be the sound wave. You will agree with me, right? Then this sound wave, they are going to cause our membrane there to vibrate. After membrane vibration, here will be vibration. Vibration. Right? With vibration happening, and then this here will be our pressure wave. Our pressure wave. So this wave here, agree, this one is going to vibrate and then vibrate that water there, or that watery liquid there. And then that watery liquid is going to form that wave, or it's going to form that ripple effect, that boom, 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 boom. It's also a vibration, or you know that the water have to do the waves like that, right? And then that wave, it's going to stimulate or excite those organ of Corti inside our cochlea. So this organ of Corti, they are going to be stimulated by these waves here. And then while stimulated, they are going to convert this wave here into our impulse. And then that impulse is going to be passed via our auditory nerve to our cerebrum to be interpreted. This is what's happening in our nutshell. So our diagram, or our pieces, we labeled them yesterday. We have our pinna. You see the label here, this everything here is a pinna, right? And then we have our auditory canal. You can see that part, the auditory and external part of our auditory canal, or our auditory matters. It's not that much important, right? From our pinna, we move straight to our auditory canal. While we are moving via that sound wave moving via our auditory canal, it's going to vibrate that tympanic membrane, or that eardrum of ours. From our eardrum of ours, we are moving straight to our ossicles, amplifying this vibration here, the hammer, the anvil, and the stirrup, right? While all these three, they are vibrating, they are going to vibrate the oval window there, which is made out of a membrane, right? Membrane here. This membrane, when it moves, when it punches that membrane, it's going to force that pressure waves there. And then the pressure inside there is going to be released by our round window. So round window is releasing the pressure and preventing the echoes of that wave inside here, right? Moving on our inner ear, we have semicircular canal. We also have the circulus and utricus, this one made vestibule, right? The semicircular canal, they have ampulla having cristae, right, or crista. So inside here we have our cochlea having our organ of what? Organ of Corti. And then this organ of Corti is going to be stimulated by this sound wave or this pressure wave, and then it's going to convert that impulse into is going to convert that stimuli, which will be the sound stimuli, right? So it's going to convert that sound stimuli into an impulse, and that impulse is going to be sent via auditory nerve to our cerebrum. Agree? Do you agree with me? Yes. Let's move on, right? This is the process of hearing. When I should be able to explain this, we also have what do we call them? This. If you sing this for the first time, mnemonics. If you are seeing this for the first time, hey, matata how? But these mnemonics, we did them when we are doing you did this when you are doing what we call replication, right? Meiosis and mitosis. When you are saying mat, these are the acronyms that we use, right? Interphase, prophase, metaphase, anaphase, telophase. So also here in our sound wave, we also have these mnemonics. These are the mnemonics, right? Acronyms that we use, or things that we use to remember the process, right? Here we are going to say pet has okak. Pet has okak, right? Pet has okak. Pet has okaka. I'm not sure. Pet has okak. Naming pinna, from our pinna, auditory canal, from our auditory canal, our tympanic membrane. This is the movement of our sound wave, right? Firstly, we are done. From there, we are going to the hammer, anvil, stirrup. We are done. From there, oval window to cochlea. We are done. OC, organ of Corti, and then A, auditory nerve, and then C, cerebrum, right? So we can write it down here. Pet has okak. Pet has okak. This is the pathway that our sound wave is going to go, right? We name them pinna, from pinna, auditory canal, tympanic membrane, right, or eardrum, right? From there, hammer, anvil, stirrup. From there, oval window, cochlea. Inside cochlea, we are going to see organ of Corti. From organ of Corti, auditory nerve, cerebrum. Right, so they can ask this question on choose column A with column B, or choose between A and D, or whatever question, that this is the pathway that our sound has to path, so that it can be interpreted on our cerebrum. Then they will start with our pinna, from our pinna, auditory canal, or our eardrum, and then here they can say tympanic, or that one that we tympanum, right? Tympanum or eardrum, right? So we can go on and see how they are placing this in our explanation. This is an explanation. This is what I was explaining, right? This is what I was explaining, now brought upon in our explanation mode. If you can take this, put it on your examination guideline. If they ask you briefly describe the process of hearing. So when we say briefly describe the process of hearing, we want to see those keywords. When I play with the keywords, play with the pinna is going to direct to the auditory canal. Auditory canal is going to transmit to our eardrum. Eardrum is going to vibrate. Vibration of eardrum is going to vibrate the ossicles, which will be the hammer, the anvil, and the stirrup. That vibration is going to transmit the vibration to our inner ear, oval. We see the oval vibrating, causing the pressure wave, causing our organ of Corti to be stimulated, or to convert that stimuli into our impulse, and then that impulse is going to go via our auditory nerve to our cerebrum, and then that's where the message is going to be interpreted, and then that's where you are going to see, or we are going to hear whatever we are talking about. This is the brief explanation, or this is the brief outline. When they say brief outline, just use those keywords. So let's see here, how are they explaining this process. But the process of hearing, right? But the pinna, here's the pinna, the first part here, you can come, sketch it, and then that 1 2 3, that 1 1 1 1 1 1 1, something like that. And then we want to see that oxygen tube there, oxygen tube, right? Then here's the thing: the pinna traps and direct sound waves into auditory canal towards the tympanic membrane, right? And then from there, the tympanic membrane, the eardrum, is going to vibrate as the sound waves strike against it. You'll understand this, right? And then from there, the vibration, this vibrating tympanic membrane is going to cause the ossicle to vibrate. And then while the ossicle vibrating, we're going to, the hammer, the anvil, and the stirrup, they are going to amplify and transmit the vibration to the oval window. Then from the oval window is this, they're just saying it, the oval window is the smaller than the tympanic membrane. The tympanic membrane is big, the oval window, it is small. So this here cause this sound here to be amplified, because the vibrating here, you can see this vibration will be big, and then while we force that vibration to come and hit there, this vibration is going to be amplified. But as the result, the pressure increases, causing the sound to be amplified there. Then from number there, we are going to say the vibrating oval window brought upon by the vibration of a stirrup. That vibration of oval window is going to cause the pressure waves. I told you that inside our inner ear, we refer them as our pressure waves. Inside our middle ear, we refer them as our vibration. Inside our outer ear, we refer them as our sound waves. So these are the keywords that you have to use, right? So the pressure wave to travel through the endolymph. I talked about this yesterday, that the liquid that is inside our inner ear that has to vibrate or that has to move, so that we'll be able to dictate the movement, is the endolymph. We have two, we have the perilymph and the endolymph. So this pressure wave travel through the endolymph. So the endolymph is going to vibrate, right? Or it's going to move, or it's going to be pressure waves, right? Pressure waved and into the cochlea. So inside the cochlea, the organ of Corti in the middle chamber. The organ of Corti in the middle chamber of the cochlea is stimulated. I told you yesterday we have three chambers: the upper, the middle, and the lower chamber. So this organ of Corti, where in our middle chamber there, they are going to be stimulated. You know, when you are stimulating it, the stimulus is then converted into the nerve impulse, which is transmitted to our auditory nerve. Right, our organ of Corti, they are converting these are the receptors, right? We learn the function of receptor is to convert the stimuli into the nerve impulse, and then this nerve impulse is going to be transmitted to the auditory nerve. And then what is the function of auditory nerve? The auditory nerve is going to transmit the impulse to the cerebrum to be interpreted. After interpretation, the pressure waves in the cochlea are absorbed into the middle ear through the round window and exit the body via the oxygen tube. I hope you understand this. When you briefly outline this, outline it with our sketch, right? Or with our mnemonics, what? Pet has okak. Something like this, right? So when we briefly the process of hearing, you do this. The pinna is going to direct to auditory canal. Auditory canal is going to be transmitted to our tympanic membrane. Here we are dealing with our sound wave. Then inside our tympanic membrane, this tympanic membrane is going to force these ossicles to vibrate, which will be the hammer, the anvil, and the stirrup, right? That amplifying the vibration. From there, we are going to see this vibrating the oval window there, where on our cochlea. So inside this one will be our inner ear. So inside our cochlea, we are going to see organ of Corti being stimulated, and this organ of Corti being stimulated, the impulse is going to be passed via our auditory canal, from our auditory nerve from our auditory nerve to our cerebrum. Then the last part here, we are going to say the pressure waves in our cochlea are absorbed into the middle ear through the round window and exit the body via the oxygen tube. When you wake up tomorrow, you are going to yawn, right? You are releasing that pressure that built inside our middle ear. So I hope you understand with this process of hearing. Do you understand it? Yes. Let's move on, right? Know this. I will advise you to know this. Pet, again, has okak. This is the simplified pathway of our process of hearing, right? Pet has okak. Pet has okak. right? Pet, outer ear, the middle ear, the inner ear. What is happening? Organ of Corti, auditory nerve to our cerebellum. So we are done with the process of hearing. Now we can move to the process of balancing, right? To maintain the balance. Two functions of our human ear for hearing and balance maintenance. So here we'll be talking about those maculae, maculae, and crista or cristae, right? But the balance is the process. This is also the process. The balance is the process in which the receptors in the inner ear detects the changes in the position of the head and respond to the gravity as well as the changes in the speed, right? And another thing, and direction of the body, right? So here we have the speed, 1. Number 2, we have direction. Number 3, we have position. So this balance here is the process that is brought upon by these stimulus. So these receptors here, they are going to recept, these receptors here, they are going to recept this stimuli and then convert it into the impulse, send it to our cerebellum so that our cerebellum can now coordinate those movement or those balances, since we know that the balance, it is maintained in our cerebellum. Agree with me there, right? So but this is the process in which the receptors in our inner ear, they detect the changes. This will be the changes, right? In the position of the head to the gravity. With the head, we are dealing with the macula there, right? And then in response to the gravity, as well as the gravity, and then as well as the changes in the speed and direction of the body. This one we are cristae. Talked about this yesterday. We talked about this yesterday, being placed like this, those maculae being placed like that. So today we are not going to talk about those. We are only going to talk about what it's being detected and how is those detected bring upon the balance to our body. Thank you. And then balance is brought about by the cristae in the ambulae of the semicircular canals and the maculae in the circulars and utriculars of the vestibule. Vestibule, yeah. So vestibule, something like this, right? So this is what is happening. We have the maculae. Where do we find these maculae? We found them inside these two sacs, the utriculars and the circulars. Utriculars shaped like U, like that. This will be utriculars and this will be our circulars, right? This inside here we have the maculas, and here we have the maculae, sorry. Here inside we have the maculae, and here inside we have the maculae, and then these two here, they are called vestibule, right? And then this process occurs as follows. So today we are going to learn this process, and then let's go and see the process. This one, what is this? This one will be the maculae. As you can see, yesterday I even told you that we have the stones up there. Those stones there, we named them yesterday calcium carbonate stones, right? So these stones here, they will move down. As you can see, you are tilting your head forward. When you are tilting your head forward, these stones here, they are going to push forward. While they are pushing forward, yesterday we talked about this jelly-like substance. That jelly-like substance is going to push these small tiny hairs here, and then this movement here is going to be interpreted and then sent via our nerve. Is going to be not interpreted here. This is going to stimulate the maculae, and then while those maculae are stimulated, they are going to produce our impulses, and that impulses is going to be sent to our cerebellum and our cerebrum, right? When you are right, when your head is upright like this, you can see our stone, they are right like that, and then the jelly-like substance there is going to keep them up there. When you move it backwards now, these crystal here, they are going to go back. These stones here, they're going to push it back, and then pushing our jelly-like substance back, also pushing our hair back. That movement there, or that shifting of those hairs there, that is what is going to stimulate our maculae. Then maculae is going to be stimulated and convert that stimuli into the impulse. I hope you get this. Also, when you shift it to the left, same thing is going to happen. When you shift it to the right, same thing is going to happen. When you shift it downwards, forward like this, same thing is going to happen. Backwards, something like this. Right up, when you go up, they are going to push down. When you go down, they are going to push up like this. So this is where we are dictating the position Here we are dealing with the position of the head, whether it's upright or tilted forward. The position, we deal with the maculae. The speed and direction, cristae. The position, maculae. Speed and direction, cristae. Right? Where do we find this maculae, Mr. Mpepu? We find this maculae on two shapes like this called the vestibule. Right? The circulus and utriculus there. This one will be our utriculus, and this one will be our circulus. Right? Respectively so. I hope you understand this. I hope you get this. I hope you understand this. Be able to explain this to someone, right? Somewhere I saw this quote today. Albert Einstein, when they say, if you cannot simplify it, you don't understand it. So if you can explain this to your friend, you understand it, and it will make you to understand better, right? While you are explaining this to, just call on your little sister or your little brother, bring him to the school, bring him here, say, come here, let me explain you something. Close your eyes, then they close that person's eyes, and then you rotate that person or remove that person forward, and then you can ask that person, in which direction are you moving? If the person said, I'm moving forward, then you can now explain to him, do you know that this process, it is happening on your human ear? On your human ear, you have cristae. These cristae, they are the ones that are detecting these motions. And while we are detecting these motions, that way now you can interpret it as moving forward or moving back. And then the speed, right? The speed, let's move on. Then now the position, right? There, now we are dealing with the position of the maculae, and then here we are dealing with they are saying the position of maculae when stationary left, and then this one will be the cristae. I'm not sure. As you can see here, we did this maculae, and then this side here, even yesterday they showed us this being our what we call another thing, our cristae, right? So allow me to cancel this position of maculae or cristae here. Crista when stationary left and when rotating right. Those cristae there, you can see this is the shape of those cristae that we learned yesterday. So this will be the shape of cristae, and then we have that endolymph here, lymph, that liquid there, right? So this liquid here, you can see the liquid is moving that direction. It is pushing this cristae of ours, and then while these cristae of ours are moving that direction, that now we can sense it and send it to our brain, and then we can now see that we are the direction and the speed, right? Here we need the speed and direction. You are rotating, we are now dealing with the speed and direction. Like if I'm rotating you at a higher speed, it means that this one will be something like that. But learn this, understand this. Let's correct here. I don't like to correct this textbook, but if we are here and if we are learning together, we will have this privilege of correcting it. This one will be the cristae, or maybe we can just go up there and prove it, right? So this one they told us yesterday, these one are the cristae. These are the cristae where in our ambula. You'll agree with me, right? Agreed. I'm not claiming. They told us yesterday this structure here looks like our cristae. So let's move on either way, right? So the circuli, maybe let's go down. Maybe they are we are done here. And then here the circuli and utriculi, these are many, right? And then one utriculus, right? Utriculae and circulae, plural, right? We learned this yesterday. But they contain the special receptor called maculae that are stimulated, right? When the position of the head changes, we talked about this, and the pull of gravity stimulates, right? When you move down, the position of the head is going to cause that changes, and the gravity there, that gravity is going to pull those stones, or it's going to pull that liquid or that jelly like in our maculae, and then so that maculae can detect that movement or that position. I hope you understand that, right? So here we are dealing with our maculae. We name them like that, right? So this is the balance. So we have the change in position. One will be the change in position when the position is changing. And then Where do we found this one will be the change of position, and where do we detect this? And then it's a position brought upon our gravity, right? And then this position, where do we see them? We found this in our circulars and our utricus, where in our vestibule, right? So this is the thing. Know these three. We have the vestibule containing circuli and utriculus, circulus and utriculus. Inside these two, we have the receptor called maculae. And then the position or the changing of position brought upon the gravity is going to stimulate this maculae, and then the stimuli is going to be sent to our cerebrum. I hope you understand that, right? And then let's do this. But the sensory hair cells in our maculae, they are going to generate the impulse. I talked about this. The sensory hair cells, these are the hair cells in where? In the maculae, they are going to generate those impulses. And then that impulses generated from maculae are sent to the cerebellum for the balance, right? We are bringing that balance. And then the cerebellum sends the impulse to the skeletal muscles to restore the balance. So this cerebellum, they are going to send the message to our skeletal muscles, or they are going to coordinate those skeletal muscles so that our balance will be maintained. When you look down, you'll understand that our spinal cord, our spinal muscles, they have to keep that head in a position. So what is causing those muscles to keep that head in position? It's our cerebellum. Agree? Agreed. We move on, right? This one is just a small piece, J. This one you can explain it in a small piece. Position, we are dealing with position. I would like you to know this. Position, where are we going to get this position being detected? Where? In our vestibule. What is it that is there in vestibule? Vestibule made of our circulus and our utriculus. And then what is inside these two? We have something called maculae. And then what is this maculae going to dictate? Is going to dictate the position brought upon the gravity, right? Position, stimuli, position brought upon by gravity. You will agree with me, right? So this one is going to dictate the stimuli, and convert it into the impulse. So it's going to detect the stimuli, convert it to impulse. From there, the impulse is going to be moved, or it's going to be transferred to our cerebellum. Here I told you that we have the vestibular or vestibule nerve, right? This is the nerve that is going to take out. We see them here. This is what Askis. Let's do this. You see them here, right? We have two nerves. This nerve here, this one will be our auditory canal, from the word auditory nerve, from in its own word, right? Audio, from audio, or cochlear nerve, right? And then this one here will be the vestibule nerve, right? You can see it's connected to the vestibules there. And then all in all together, they are called vestibulocochlear nerve. Or in some books, also in our study guide, our Mind the Gap, they said these impulses here, they are transferred or they are sent via our auditory nerve. So if you are going to say these impulses that we are talking about here, they are going to be transferred to your brain via auditory nerve, they will give you that marks, right? Because in our textbook and in our study guide, same thing. They say same thing. So let's study our balance there. We did our position there, and this one here, we are dealing in the ambuli. We are dealing with what? With the speed and what? And direction. I told you yesterday that those canal there, they have liquid, those endolymph, and this liquid is going to enter here, and then when it reaches that ambula there, this will be our ambula, right? When it reaches this ambula here, we see that it has those structure called a cristae. When this water hit this cristae is going to go down, and then that will be the stimuli, and then that stimuli is going to be converted into the impulse, and that impulse is going to be sent to our cerebrum and cerebellum. Right here, we send it to cerebellum so that it will maintain that balance. When we talk about the balance, yes, there's some nerves that are going to our cerebrum, but because we are dealing with our balance, so that our cerebellum will our cerebellum will send that impulse to our skeletal muscles. We will concentrate on the nerve that is taking that, or that is transmitting that impulse to the cerebellum. Agreed? Agreed. So the ambula there, the ambula but are situated at the end of semicircular canals, right? There. They contain cristae there, right? So now you should be able to sketch this. Canal. Then at the end of canal, we have that ambula, and then that inside ambula, we have those cristae at the end. And then these cristae, they are the receptor recepting or detecting the change in speed and what? And direction. So this speed and direction is going to cause, or is going to be stimulated there, or is going to stimulate this cristae. I told you, right? So the liquid, when you shift, when I come to you and shift you to the left or shift you forward, the liquid is going to enter here, rush here, and then it's going to stimulate that, right? So this is what is happening, and then when we explain it this side. But the three semicircular canals are positioned in three different planes, right? The planes here that I told you that we have bony lady ring, right? Bony lady ring. Cavity yesterday, right? Cavity or bones, right? Lady ring like that, right? So in this lady ring, those planes there will have a canal that it is at its own cavity. We also have another canal that is its own cavity. We also have another, it's canal, three of them in its own cavity. So those canals, they are situated in a place where, or they are situated in a position where when you shift your head forward, when you jab it, when you forward, that water is going to enter there, or that endon lymph is going to enter, right? So they are positioned in a different plane. So they are positioned in a different structure, or in a different position. Mudimu, guys, God created, when he was creating you, he created these semicircular canals in a position that he made sure that when you move to your left, when you move to your right with the speed, right, the macula there, it also going to dictate that position. But when we want the speed and direction, I'm moving to the left. At what speed? 10 kilometers per hour. Or at what speed? Maybe slower or fast. I hope you get that. So, and therefore, any sudden changes in the speed and direction of the body movement causes the endon lymph, the liquid that I was talking about, that to move in at least one of the semicircular canals. This is what I was explaining, guys. The God created this so that in a perfect position, that when you move a certain movement in your body, is going to cause this endon lymph to enter one of the canal. When it enter that one of canal, is going to rush here and cause this crystal of ours to move. But the movement of endon lymph stimulates the cristae to generate the impulse which are sent to the cerebellum. What are they going to do in our cerebellum? They are going to maintain that balance, right? That cerebellum here has to remove another impulse to our skeletal muscles, so that you will prepare yourself. When you are moving forward in a car, you know that you are moving forward in a car, and then that muscles, they have to keep you still. You have to remove the posture when you are riding the bicycle, right? And then the cerebellum will send the impulse to the skeletal muscles to restore the balance. With that being said, my name is Mr. Pepu. We are done with today's lessons. Let's meet tomorrow when we are doing question and answer regarding these questions, how they bring these questions on our textbook or on our examination end of year or June, right? So you are here. So let's do that. Let's do this. We have the ambula there. Well, the ambula, where do we find this ambula? We found them in our semicircular canal, right? So we are going to say the ambula. We're going to say the ambula. Where do we find them? In our semicircular canal, semicircular canal. And then what do they have? They have cristae. And then these cristae, they are going to be stimulated. Stimulated by what? By the speed and direction of the head. Right? While they are stimulated, they are going to do what? They are going to convert the stimuli, because they are the receptor. They are going to convert the stimuli into the impulse, right? Then with the impulse is going to be sent to the cerebellum. As you can see here, they didn't include the nerve that is sending these messages to the cerebellum, right? They just saying that this one will be sent to cerebellum. By what? They didn't include it. But let's go to our MTG first, since we still have time. With our MTG, this is the process of hearing, right? With our MTG, this is the process of our hearing. But the below shows the three parts of the ear work together to make it possible for us to hear, right? The gray arrows shows the path of the sound wave. We are done, right? So this one will be the sound wave here, the vibration here, our pressure waves, right? So you can see our ear canal, our auditory canal, our tympanium or tympanic membrane or our eardrum. We can see our pinna directing those sound waves, and then our auditory canal transmitting that sound wave, and then our tympanic membrane vibrating, causing our hammer to vibrate, hammer causing our anvil to vibrate, anvil causing our stirrup to vibrate, called the ossicles, right? Three of them. And then this vibration here is going to be transferred via our oval window. This oval window there is going to form, this is the membrane that is going to force that pressure waves there. The water inside called the endolymph. We want to find this water here vibrating or moving, right? Those water lymph is going to vibrate up until it reaches the cochlea, and then inside the cochlea we're going to see those organ of Corti, and then those organ of Corti, they are going to transmit, or they're going to convert this stimuli here into an impulse. Then from the impulse, we see that impulse being transferred via our auditory nerve to our cerebrum. That was it, right? Then these two, they are functioning on our balance. Semicircular canal, ambula cristae, circulus and utriculus. You know, the first one is utriculus, the second one is our circulus. They have maculae, they are called vestibule, and they are sending the message. So let's go and let me show you what I was talking about, right? So this one is the part I was doing it. P has ok, like that, right? So this was the part of the ear, the pinna, the tympanic membrane, the ossicles, the oval window, the cochlea, and the auditory nerve, up until to our cerebrum, right? You know, the pinna, it is directing and it's stripping the sound, directing them to the auditory canal. The auditory canal is going to transmit the message or the sound wave to our tympanic membrane. The tympanic membrane is going to vibrate and transmit the vibration to our ossicles in the middle ear. Then the ossicles, they are going to vibrate and going to amplify the vibration and carry them via the middle ear to the membrane of our oval window. The oval window there is going to vibrate, and while it's vibrating, it's going to cause the pressure waves in our inner ear. Inside our inner ear, the pressure waves, they are going to reach our cochlea, and then these vibrations here cause the sensory cells in our organ of Corti to stimulate, to be stimulated in cochlea, and nerve impulses are generated. So this organ of Corti, they are going to be stimulated and convert the stimuli into our impulse, right? So this impulse is going to via our auditory nerve, and then it's going to be transmitted via the nerves and then to the cerebrum to be interpreted. I hope you understand this, and I hope you know this, and I hope you can briefly outline this, or you can briefly say this, right? Pinna, auditory canal, tympanic membrane, hammer, anvil, stirrup, oval window, cochlea, organ of Corti, auditory canal, auditory nerve, and our cerebrum. Pet has okak. Go and comment on the comment section. Pet, go just comment this. Pet okak. Pet has okak. Then the balance there, we are dealing with the balance, but the hearing is responsible for balance in this way. We talked about the cristae and the maculae. The cristae in a semicircular canals, where in a semicircular canals in the ambula, right? The ambula has stimulated by the changes in the direction and the speed. So the direction and the speed is for the cristae, and then these maculae in the circulus and utriculus, where in the vestibule, right, are stimulated by the changes in the position of the head, right? Back. You are stimulating this, right? And then when stimulated, these cristae and maculae convert the stimuli received into an impulse, the nerve impulse. And then the nerve impulses are transported along the, you see what I was talking about. It is transported along auditory nerve. So here in this textbook, they are using, I'm not sure, but they are using auditory nerve. But with our learning or with our understanding, we told you, or we learned, that we have two types of our ear nerve. nerves, right? The one called the vestibule nerve, and the other one called auditory nerve, right? So the auditory nerve, cochlear, organ of Corti, auditory nerve to cerebellum. And then these two, as you can see with your textbook, they are also referring to this nerve as an auditory nerve. I'm not sure why, but if we're now, you can say this and then say auditory nerve, they are going to give you that right. They're not going to penalize you for saying this stimulus here, they are conveyed or they are transported along auditory nerve to our cerebellum to be interpreted, right? So they will give you, although this one here, I will maybe comment on the comment section. Maybe I'm saying something that I'm not sure, but we learn it on our textbook. We saw it on our everywhere. We see these two. From our vestibular there, we have the nerves, and we also from our cochlear there, we also have the nerve. Both of them, they are called vestibulo-cochlear nerve or vestibulo-auditory nerve. Go and Google this if you have time. But if you name them like this, it's fine. So the nerve impulse are transported along the auditory nerve of the ear to the cerebellum to be interpreted. The cerebellum then sends the impulse to the muscles to restore balance. When you are falling to the left, the cerebellum is going to send the message to our muscles so that you pull back your head. So tomorrow we'll be dealing with the question and answer. This one will be Thursday, right? This one will be Thursday, and then the revision of this human ear. Then from there, we are done. Let me not waste your time. My name is Mr. Mpepu, bringing you this life science. It's just that we are bringing back to our community, right? To our African brothers and sisters, to our South African brothers and sisters. It's just that we don't have money, my guy. If I had money, I would be maybe giving food on the hobos out there, or I might be giving whatever, building houses, changing someone's life out there. But because we don't have those money, we don't have those means, this is the means that we can give back to you guys. Learn this free of charge. After learning this, go and make your family proud of you, passing life science with distinction. Go and be doctors, go and be the specialist, the optometrist, the genetic counselor, whatever that you are going to be, the dentist, whatever that you are going to be that is related to life science, guys. So go and learn and be the right person. If you know the best, you will do the best. My name is Mr. Mpepu. Until we meet again tomorrow. Hotsong aibelilina, mudalobe na watu wote, kurula kobe nani, uktula kobe nani. Until we meet again, guys. Thank you. And then tomorrow, let's do this. Tomorrow we'll be dealing with this, and then if you want to do the activity, we will include this activity tomorrow, right? Activity 9. Let this be your homework up until somewhere, because we have been done our defects, right? This one, we are going to remove it. So this will be the part, and then up until osteosclerosis is the genetic form of hearing loss caused by stirrup becoming this one we can answer it. And then number 3, 2 devices, this one will leave it because it's dealing with our defects, right? The vestibular branch of auditory nerve transmit impulse from the semicircular canals to the cerebellum. You see, the vestibular branch of the auditory nerve transmit impulses from the semicircular canals to the cerebellum. In this textbook, they have it right. Those are the vestibular branch using vestibular nerve transmitting the impulse, this part, right? Explain the consequences if this nerve it is infected by virus. So you can also answer this, right? We have 2 nerves here. You can see that they want to implement those 2 nerves. We have the auditory nerve, and we also have this vestibular nerve. This vestibular nerve is bringing about the balance. So if it is affected, it means that your balance is going to be affected. You are going to fall. You are not going to maintain the upright posture, whatever you can come up with. But know that there's difference between the two. We have auditory nerve and vestibular nerve. Thank you. Until we meet again tomorrow. Those who are watching me during night, I also watch these videos during night. You can say I post them now, and then Boma 10, 11, 12, I rewatch them. Learning or seeing if someone was watching this, what is it that the person is going to learn? How is it going to learn? And how am I saying things? Those mistakes that I was talking about, how do I rectify those mistakes, and how do we move on, right? We are building one another. I'm becoming the better teacher or the better educator, you are becoming a better learner or better student. Also being able to interpret the textbook that you are given, and also being able to use the textbook that you are given together with the study guides, right? This system, you can also use it university, being able to decode the question paper, being able to decode the textbook that is being recommended for that module. So with that being said, guys, thank you. What did I miss? Nothing. Until we meet again tomorrow, comment, guys, subscribe, guys. The only thing that I would like you to do is to comment and subscribe and like, guys. I don't have much. Gold and silvers I don't have. I only have these to offer to you. Right? So thank you. Until we meet again tomorrow. Peace. Peace. Peace.